How close are we to another Carrington-style event, and how bad will it be? Why do people keep calling interstellar comets alien spaceships? Why not shift our focus from Alpha Centauri to Tau Ceti? And in Q&A Plus, if we see the universe in the past, do we have a model for how it looks right now? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write them down. I'll gather them up and I will answer them here. All right, let's get into the questions. J. Garrick, Fraser, what plans are in the works to capture a sample from an interstellar object? Wouldn't that be amazing if we could get a sample from an interstellar object? I mean, we have all these questions about how do other star systems form? Do they have the same kinds of chemical composition as we have here in the solar system? Or do they have something totally different? And we just don't know the answer to that. Like, how could we know? Well, we can know because the universe is throwing samples of different star systems at us. And all we have to do is catch them. So as soon as the first interstellar object Oumuamua was discovered, people were proposing different kinds of missions that could try to chase it down and study it up close. And then people started to think about, well, if there's going to be future interstellar objects coming through the solar system, could we somehow intercept one? And so missions have been proposed, designed to intercept comets and interstellar objects. The European Space Agency has gotten the furthest along with this. They've designed and we're planning on launching a mission called the Comet Interceptor in 2028 as part of the Ariel mission. So it would be sort of like a small spacecraft that would fly with Ariel. And then it would go out to the Earth-Sun L2 Lagrange point, which is sort of like a balancing place of gravity, and then would wait for a target. And then when a target came into the solar system, either an interstellar object or some kind of long period comet, then it would perform an interception and fly past it and take a bunch of images as it flew past. So that would be like a first step. But as you said, the thing we really want is we want to bring a sample home. And so we've done sample return missions from comets in the past. The Stardust mission flew through the tail of a comet and then brought that material back home to Earth, and scientists have been studying it to this day. So you would probably do something like that, which is that you would send something like Stardust. It would hover out at the L2 Lagrange point, wait for a target to show up, and then do a flyby and pass through the tail, but then follow a trajectory that brings it back to Earth so it can deliver its payload, and then scientists can study that. Now, there have been sort of even more elaborate ideas that would require some kind of exotic forms of propulsion. So one idea is that you could just take an RTG, a radioisotope thermoelectric generator, like a decaying chunk of plutonium, and it is producing heat. And then you would just bolt it onto an ion engine. So the ion engine is then producing the thrust. It would be very little to this spacecraft, and it would be able to accelerate quick enough to be able to catch up with an interstellar object, and then deploy a probe, and then maybe even be able to bring a sample back home to Earth. So it would be a tremendous engineering challenge for us to be able to do this. But if we did, it would be so much easier to collect samples of other star systems from interstellar objects than it would be to try to actually go to other star systems and collect samples directly. So for the next few centuries, the best chance we have of studying other star systems is from interstellar objects. Bradley Fitzik, why does Avi Loeb keep calling this an alien mothership? I have no idea what the motivations are of people who are calling Comet 3I Atlas anything but a comet. It's possible that they genuinely are looking at it and looking at its size, because it is surprisingly big, and it is moving surprisingly fast. That this is by far the fastest interstellar object that we've seen coming through the solar system. They're looking at the fact that it's going to be hidden from the Earth when it hits its closest point to the sun. That's weird. It's going to be doing relatively close flybys of Mars, the sun, and Jupiter. That's interesting. So those are things that are interesting coincidences. But then there are other things that are just totally comet-like. It's grown a coma. It has grown a tail. It is moving exactly how you would expect an object that is moving through the solar system, interacting with the gravity of the sun to behave and move. Hasn't done anything weird. So on the charitable side, and there are lots of channels here on YouTube that are doing a lot of speculation about this. On the charitable side, something in this they find compelling, and they're sort of running with their hypotheses. And on the uncharitable side, they're, they know that this kind of thing is very exciting, and that a lot of people want information, and we want to know about aliens. And, is this the one that tells us the aliens? And so, there's a certain amount of playing to that audience. So far, all the reporting that I've done on this, and like we have reported on it week after week after week, and it's mostly, here's some pretty pictures. It's a boring comet. Look at these cool pictures. Here's some ideas on how we could send a spacecraft to it. We'll continue until it is out of sight. And then we'll wait for the next interstellar object, and then we'll observe that one too. And it will do exactly normal, boring comet-like things, because that's just how it works. And it would be amazing if it was aliens. Like, that would be the greatest thing ever. I can't wait to be wrong. But if I am wrong, I want to know for sure that I'm wrong, not have a slight hint, maybe copium, that I'm wrong. Lee Marinus, how does one tell if a comet has a tail if it's coming straight at the Earth? Well, everything is following an orbit. And so there isn't an orbit that is going to come straight at the Earth, that you're always going to be seeing the comet from different angles as it is moving through the solar system. And the Earth is moving in its direction, and you're going to be able to see the comet and see the tail. And also, we have other spacecraft in other places. We have spacecraft at Mars. We have spacecraft at Jupiter. We have spacecraft at Venus, although not anymore. We have a spacecraft going to Mercury. We have spacecraft approaching the sun. We have spacecraft at many different points around the solar system. And so you can look at the comet from different angles. James Webb Space Telescope, Hubble's by Earth, but James Webb's a little off away from Earth. So, you can get a different perspective. New Horizons, way out at Pluto, past Pluto. Could take a look. So we've got lots of eyes in the solar system now. Tim P, have we seen any Carrington-like events since the actual Carrington event, but pointed in the opposite direction from the Earth? Yes, we have seen events that are more powerful than the Carrington event, just not pointed at Earth. So we know the sun is continuing to do this on a regular basis. We just have been lucky so far that one hasn't been directed at us. San, would a modern-day Carrington event not be as destructive because electronics are more resilient instead of being glass shards of electrolytes and iron rods stuck in the ground? Nope. It would be very destructive because, it's all about jamming electrons through wires. That's the telegraph poles caught on fire in the Carrington event. And so imagine all of the telegraph poles that we currently have in all of our modern electronics, all of the transmission lines, all of the internet lines, all of the circuitry, all of the routers, the entire internet, all of the satellites, all of the wiring, everything has the potential to be fried. And so if an entire electrical grid can't suffer one big transmission line going down, and it's inevitable, so, a Carrington event would sort of short circuit or overload wires across our entire electrical grid. Satellites will go offline. Electronics stop working. Cars will stop working. Like, we don't know. Not everything is going to stop working. Some things will be great and totally resilient and handle it no problem. But, we already know that our electrical grid is creaky at best. And so it does not need the insult of an enormous surge of electrons moving through it. It's time to shout out the new $5 patrons and above. Syntheris, Cynthia Adams, Christopher Say, James Porter, JG, Cody Quest, Jerry McDonald, Justin Rogers, David Warren, and John Nilsson. Join the club at patreon.com/universe today. Siddharth Rai, what is the strongest motivator for humanity to attempt an interstellar probe with a camera, other than the possibility of us going extinct? Because we're curious. We want to see what another star system looks like up close. So that's the motivator, not about us potentially going extinct. I want to see what another star system looks like up close. Daniel Verberne, Do you think there is some chance for M-dwarf stars to host habitable worlds? So, not an astronomer, journalist, but I have asked this exact question to astronomers. And the answer that we get is they don't look great. They look like very bad stars. If you wanted to have a habitable world next to an M-dwarf star, the problem is, these red dwarf stars, they have these terrible flares. They have flares as powerful as the sun, more powerful than the sun. And the planets have to be very close to the star to be able to receive some of the sunlight and to be in the warm habitable zone. As the planets are tidally locked to their stars. So the habitable side of the planet is always facing at the star, facing the flares. The flares are hitting. And every single simulation and calculation that astronomers make show that these close-up planets are going to have their atmospheres stripped away within a few 100 million years early on, not long enough. They won't be able to survive long enough to be able to have thicker atmospheres form, protect life, go on to have a habitable world. If you can get past that first billion years or so in the age of a red dwarf star, then the star settles down, and then it actually is a great place to be for a long, long time. But you got to be able to survive that really bad early billion years. But other simulations show that once you get far enough away, say in the TRAPPIST-1 system, that the first 4 planets are going to be bombarded by radiation. But maybe at the 5th planet, things look good. The 6th planet, things are starting to be okay, right? The 7th planet is outside the habitable zone again. So you have this really tiny little zone. But red dwarf stars are the only stars that we can study right now. That James Webb does not have a coronagraph that's good enough to be able to see Earth-sized worlds orbiting around sun-like stars. It can only see Earth-sized worlds orbiting around red dwarf stars. And so those are the stars that astronomers are looking at, because that's what's possible right now. And if you came to astronomers, 10 years, from the future, astronomer from the future comes back and says, all right, well, we looked at every single red dwarf planet that we could, and none of them had atmospheres. Today astronomer, you would go, yeah, that sounds feasible to me. That sounds right. It was a long shot, but we were hoping. But maybe the future astronomer comes back and says, the universe once again did something we were not expecting, and that for some reason, planets around red dwarf stars have figured out a way to have thick atmospheres, and they seem to be in the habitable zone, and there could be life there. And we even detected a biosignature. And today astronomer will go, yeah, that sounds reasonable to me. I'm not surprised. So right now we're in this in-between state that James Webb has examined several red dwarf stars and their planets in the habitable zone. And so far, no atmospheres for any of them, but we can't rule it out forever. Makayla Sol-Speed, why does the space community focus so much on Alpha Centauri when Tau Ceti is also close to us and has 9, maybe 10 planets? Why not care more about Tau? Tau Ceti is just shy of 12 light years away from us, compared to just over 4 light years for Alpha Centauri. So Alpha Centauri is much, much closer, right? It is the closest bright star in the sky. Of course, Proxima Centauri is even closer. And so Tau Ceti is further. Once you get out to 10 light years away from us, there's about 100 stars within that volume of space. So, instead of just Tau Ceti, there's a whole bunch of other stars that you could think about as well. Most of them are red dwarfs, but still. Now, I'm not familiar with all of those planets. From what I know, there are 4 unconfirmed dubious planet possibilities, but nobody has been able to confirm them. So, all of the close by stars are targets of continuous exploration by planet hunters. So you'll see a lot of emphasis because these things are close. And so if you're able to find a planet orbiting around a star that is only 12 light years away from us, compared to finding planets that are 1,000 light years away from us, you've got a much better chance to be able to study it once you actually are able to look at it. Sam B, could space be part of war strategies in the future? I mean, it already is. Right? There is Space Force. There's already a part of the US military that is concerned about space warfare. Now, like communication satellites, like weather satellites, they're directing this back at Earth, right? Which is like, how do you destroy enemy satellites? How do you protect your satellites from being destroyed by aircraft launching missiles at them? So that's what people are focused at right now. But you can imagine the satellites will have to maneuver away from each other, have countermeasures to be able to stop rockets from hitting them. And it becomes more and more complicated. And eventually we've got Space Marines. That's how that probably works. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And this week's bonus question: if we see the universe in the past, do we have a model for how it looks right now? And I'll put a link in the show notes so you can watch that right now. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. The next live show is going to be 8 a.m. Pacific time, which is going to be perfect for people in Europe. So I'll put an event here on the channel so you can click to remind yourself that this thing is going to happen, especially you Europeans. We're doing this for you. All right, I'm going to talk about the most influential movies in my life. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Carrington, Chuck Hawkins, Commander Balak, Cy Nelson, Dave Verabioff, David Giltonan, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Monzo, OneStepForAnimals.org, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Okay, so last episode, I told you what were the most influential TV shows for me. And now I'm going to give you my top 10 influential sci-fi shows-ish. These are in alphabetical order, so I'm not going to necessarily count them down. So the first one is Aliens. And I was sort of like 14 years old when Aliens came out, and I watched this in the theater, and it both sort of scared me, but also it was just so exciting. It was just an incredible movie. So definitely Aliens. Next up is Dune, the recent version, the 2021 version by Denis Villeneuve. And it was just like such a proper telling of the Dune story and sort of captured the essence that sort of doubles down in the next movie as well about sort of what really the Dune books are about. And it looked incredible, and it felt very accurate to the books. Next up is Ex Machina, and this is a movie directed by Alex Garland, who is one of my favorite writers, directors. And this just felt like a chilling sort of vision of the future of sort of artificial intelligence. Next up is Star Trek II, The Wrath of Khan. And I was a little younger when I watched Star Trek II, and it really freaked me out at the time. But it was also very exciting, and I've gone back and watched it many times, and just, the best Star Trek movie by far. Next up is Star Wars. And, while I don't think Star Wars holds up to other movies on my list, it was just such an influential movie for me. 1977, I was 6-7 years old, and it was like somebody had made me a movie that had all the things that I was excited about as a kid. And I tried to get my kids to watch it, and they just really didn't like it. But Star Wars is definitely there. Next up is Arrival. And this is a much more recent movie, another Denis Villeneuve movie. And this is like trying to wrestle with how do you communicate with a truly alien intelligence. And I just found the movie gripping from beginning to end. Next up is The Iron Giant, and this is an animated movie and just absolutely incredible. Beautiful story told, great animation style, and still one of my favorite movies that I go back and watch. And, it was the kind of movie I could watch with my kids as they were growing up. Next up is The Martian, and this is just this is a cozy movie for me, where it has this great story told in this very kind of casual, jokey sort of style, and yet it has some serious stakes, and the special effects were really good. I really enjoyed it. Next up is Tron, and this is the original one, back in the 80s. I was very young, maybe like 11 years old or so. And when I watched that movie, it blew my mind. I couldn't get out of my head. I watched it many times back in the theater. I was nagging my parents to let me go and watch it. And clearly, this was like some sort of harbinger of the future of my fascination with sci-fi. And last on the list is War Games. And this came out in like 1983. So around the same time as Tron, and sort of same thing. I was at this time of my life where these kinds of movies really would resonate with me. And again, like you watch these movies and they feel like they've changed you after you watch them and you can't get them out of your head. And that's what War Games was for me. And like possibly the most influential movie that I've ever watched. Like maybe really think about computers and networking and global thermonuclear war. Yeah, it was great. So that's my list of the most influential movies for me. I would love to see your list. Go ahead and put your list down into the comments below. All right, we'll see you next time.